Okay, so when you have 0, then the problem is that when you want to calculate for the next rows, then you will get more zeros. So this is a problem for Routh Hurwitz calculation. So you need to do some modification on the method. Okay, so we look at the first case, which is 0 in the first column. Okay, so let's say you are given a transfer function. So TS here is a closed loop transfer function. Okay, so you don't need to do the block diagram simplification. Okay, so when you are given a transfer function TS, let's say you are given here. So first thing is you need to make a Routh Hurwitz table with the highest row as 5. Okay, s to the power of 5. Okay, so whenever you have denominator s to the power of 5, then you know that this system has 5 poles. Okay, so poles means that the number of roots of the denominator. So when you have here s to the power of 5, meaning that you have 5 poles, but you don't know the poles. So the only way you need to know the poles is by factorizing the denominator. But here the equation is long, so it's hard for you to factorize. So instead of factorizing, we use Routh Hurwitz criteria to check for the stability because it's easier. So here you have 5 poles. Okay, so the first step is you create a table. So the highest row is s to the power 5, and then followed by s to the power 4. And then you fill the table with the coefficient of the denominator alternatingly. So here s power 5 is 1, and then 2 on the bottom, and then 3, and then 6, 5, and 3. Okay, so this is your first 2 rows for the Routh Hurwitz table. And then after that, you calculate for the subsequent row. So first is the row S3. So when you calculate S3 using the determinant 1, 2, 3, and 6 here, so you will get 0. So whenever you get 0, what you need to do is you have to define a small number or small variable. We call this here we call this epsilon. So we put epsilon to represent a very small number. Okay, so replace the 0 by epsilon. And then we continue calculate our table. Okay, so here we put epsilon. And then here you calculate from the determinant above. So 1, 2, 5, and 3 divided by 2. And then 0 here is 1, 0, 2, 0 divided by 2. Okay, so you just continue as usual. And then for the next row, the row S2, so you continue calculation as usual, but now you use the epsilon. Okay, so here what you need to calculate for this box is that you need to calculate the determinant. So the determinant comes from the value 2, epsilon, 6, and 7 over 2. Okay, and then divided by epsilon. So you get these terms here. Okay, and then here 3 you get from 2, epsilon, 3, and 0 divided by epsilon. So you get 3 only. And then here you get from 2, epsilon, 0, and 0. So you get 0. And then for the next row, for the subsequent rows, you just calculate as usual. Okay, but now your box has epsilon in it. Okay, so the values in the first column will be in terms of epsilon. And then after that, after you calculate, then you can determine the stability. Okay, so how to determine the stability whenever you have epsilon? It's not a number. So what you need to do is, so first you need to check when the value of epsilon when it's positive and negative. Okay, so you assume the epsilon is positive first. So for example here, the first row here you get positive, and then S4 here you get positive, and then epsilon here you assume it to be positive. Okay, so you put positive here. And then on this box, whenever you assume epsilon positive, so let's say epsilon is maybe 0.1, for example. So 6 times 0.1 minus 7, you get negative 0.9 or some negative values. So here it's negative already. Okay, so you put negative. And then on row S1, you also assume epsilon as a small number but positive. Maybe we put 0.1 here. And then when you calculate, you get positive number. And then lastly, 3 is positive. So here you can check that there is one sign changes here. One sign change from positive to negative. And then from negative to positive is another sign change. So there are two sign changes. Okay, then you need to try for epsilon equals to a negative value. Okay, so the same thing, positive and positive for the first two rows. And then for the third row, you assume epsilon as negative, let's say negative 0.1. And then here, you substitute epsilon equals negative 0.1. So you'll get positive value. And then here also the same thing. You calculate and then positive and also positive. So here there are two sign changes also. So from positive to negative and then from negative to positive. Okay, so how many sign changes? There are two sign changes. So meaning that there are two poles on the right half plane of, of the S plane, okay? So here the system is unstable. Okay? Boleh dapat? Okay, so this method seems troublesome because you need to assume epsilon as a positive value or negative value. Maybe it will be confusing to some of you. So we have an alternative method, okay, for the case when you have 0 in the first column. So the alternative method is that first you need to, of course, determine that the case will get 0 in third column here, S cube, S3. So after you get 0 in the third column or in this, or no, in the third row here, then you can use the alternative method. So the alternative method basically is that you reverse the coefficient of the denominator. So here is your transfer function earlier. So if you know that this transfer function will produce 0 in the first column, then you reverse the coefficient, okay? So here, s to the power 5. So the coefficient 1, we replace with coefficient 3, okay? So we reverse. And then here 2, we reverse with 5, okay? And then here, coefficient 3, we reverse with 6. And then 6 here, we reverse with 3. 5, we reverse with 2. And 3, we reverse with 1. Okay, so you just reverse the coefficient. After you reverse the coefficient, then you can continue doing the table as usual, okay? So here you start with s to the power 5, followed by s to the power 4, and then you fill the two rows, the first two rows alternatingly. So here you start with 3, 5, 6, 3, 2, and 1. Okay, after that you calculate S3 using the determinant, the same thing. And then you will see here you don't have 0 anymore on the first column. So it's easier to use alternative method. But if you understand the first method, you can also use the first method, okay? So here you see that there is two sign changes, okay? From here positive to negative, and then from negative to positive. So the same results, you get two sign changes, meaning that you have two poles on the right hand side of the S plane, and also the system is unstable. Okay, boleh dapat? Alright, so if you understand, you can try quiz number 10, question number 1, okay? And I give you around 10 minutes, and we continue back around 10:35, okay? Any question, just ask, okay?
Zaim, awal Zaim.
Siap dah Zaim?
Dah lagi.
Zaim kuis 4 hari ni Walau kuis 3.
Apa tu Miza?
Zaim, nanti logik tau.
Zaim left. Sedih ke? Dia nak merajuk ke?
Awal sangat maju. Dia baru kuis 4.
Ke dia pergi hantar quiz by mail, surat post.
Dia buat kuis 4 je.
Quiz 4. Aduh, jangan merajuk.
Nak tanya saya?
Yes, okay.
Yang table yang sebelum ni, saya cakap epsilon tu dia nilai kecil kan? So nilai epsilon tu di bawah 1 ke? Macam 0.1, 0.2 macam saya cakap
Ya, lebih kurang macam tu lah. Kalau korang pernah belajar limit dulu kan, masa form 5 ke, pasal limit, macam epsilon tu a very small number. So kita ambil lah nilai yang kecil like 0.1 ke 0.01, okay? Supaya kita just nak tentukan sama ada nilai ni positif ke negatif. Tu je.
Lepas tu macam mana nak
Baiklah Syaf.
Rasa macam mana nak tentukan positif dengan negatif je? Saya
Macam mana nak negatif? Okay, ambil calculator. Lepas tu letaklah epsilon ni, let's say 0.1. Then kira lah 6 darab 6 times 0.1 minus 7, you get around 0.9, right? Negative 0.9. So negative 0.09. Okay? So you put negative here. So the first method is difficult, okay? Because you need to macam imagine how the value will be when you put epsilon as a very small number but positive. That's why you can use the second alternative method. Alternative method is easier, but you need to first do the first 2-3 rows here. After you get 0 here, then you know that there is a 0 in the first column. After that baru buat alternative method, meaning that you reverse the coefficient. So reverse coefficient, dia punya method tak perlu letak epsilon dah. Okay, you don't need epsilon for reverse coefficient method. So you will get no zeros in the first column, and then you get the same result, which is the same sign changes here, 2 sign changes. So sama dengan previous result, okay? So kalau confused dengan epsilon method, boleh guna alternative method. Alright.
okay sir, thank you.
Okay.
Sir. Quiz yang soalan nombor 1 tak
Ya.
tak kisah kita nak buat mana tu. Method mana tu. Tak kisah.
Tak kisah sebenarnya sebab soalan ni dia open, okay? Dia open. So you can carry out method number one. Method number one basically is the tadi lah when you have zero in the first column. But kena tentukanlah dulu ada zero tak in the first column. Tak ada zero pun, tapi kena tentukan dulu. Bila dah tentukan ada zero dalam first column, baru restart balik, reverse coefficient, and then start balik buat table tu.
Okay, sir.
Alright.
Sir, nanti video serekod ni upload kat kalam
Tak, dekat YouTube. So sila subscribe
Channel
to my
sir.
YouTube channel,
Oh.
Jamil X Gaming.
Alright, sir.
Apa dah?
Saya akan subscribe.
Okay. Okay. Okay, kelakar lah korang ni. Alright, so any question for question number 1? Okay, kalau tak ada question, kita continue for the next topic. For the next
Dan-
subtopic.
Sir,
Huh?
the system is unstable. Unstable.
Unstable
Unstable,
tak? Tak tahu, saya tak kira.
tak apa.
Okay, yang penting korang tahu method je, okay? So you know the method. If you have 0 in the first column, then you can choose to do the alternative method or to do the epsilon method, okay? And then after that, you can determine whether have sign changes or not. Okay, so basically Routh Hurwitz criteria or Routh Hurwitz method is important for subsequent chapter. I think chapter 4, okay? Chapter 4 will be about drawing graph, or we call it root locus. So in drawing root locus later, there are a lot of methods, a lot of techniques that you need to remember. And this is the one of the most difficult chapter for automatic control. Most of the student senang dapat kosong dekat chapter root locus. So one of the technique is to use Routh Hurwitz. So Routh Hurwitz, you need to really understand on how to do the table to calculate the determinants. Okay. Okay. So now we move on to the next subtopic. Okay. So what happened if you encounter a case when there are zeros in the entire row, meaning that one of the row has all 0. So just now it's one of the column has a 0, but now all of the rows, or no, one of the row has zeros, all 0. So here, for example, you are given a closed loop transfer function here, TS, and then first you need to fill the Routh Hurwitz table with the first two rows s to the power of 5 and s to the power of 4. Okay, so you fill the first two rows. Okay, so row S4 here you can simplify, but you can choose to not simplify. It will produce the same result. Okay, so if you confuse on simplifying the rows, you can choose to not simplify. It will produce the same answer. Okay, but now after you get row S4, then you try to calculate row S3, you get all 0 in the rows. So not only 0 in the first column, but 0 in other columns as well. So whenever you encounter zeros in the entire row, then you need to do some modification on the method. So what to do? So first you need to look at row S4. So in the row S4, there are 3 coefficients, 1, 6, and 8. So you use this coefficient to form a new polynomial. Okay, so the polynomials will start with s to the power of 4, but with coefficient 1. And then the second terms is s to the power of 2. So s to the power of 4 and then s to the power of 2. So the coefficient for s to the power of 2 is 6. And then lastly is s to the power of 0, or no s, okay? S to the power of 0, but the coefficient is 8. And then what you need to do next is you need to differentiate the polynomials, okay? So you differentiate PS, you will get 4s cubed plus 12s. And then next you need to use the differentiation of PS. You use the coefficient and replace and put it in the row s cubed. So 4 you put in the first box, 12 on the second box, and 0 on the third box. Okay, so now you replace the row s cubed from 0, 0, 0 to 4, 12, and 0. So the step is first you need to look at the row above the row zeros. So here in this case, row zeros is s cubed, and the row above it is s to the power of 4. And then you define a new polynomial. So here, s to the power of 4. So let's say if this is s to the power of 5, then you will start with s to the power of 5, s to the power of 3, and s. But here it's s to the power of 4, so you start with s to the power of 4, followed by s squared, and s naught, or s to the power of 0, or nothing, okay? And then you use the values in the row as the coefficient. After that, you differentiate the polynomial, and you use that differentiation, the coefficient of the new polynomial, or the differentiated polynomial, as the values for the row s cubed, or the rows that contain 0. So the rows will will change from zeros to a new values. Okay. And then after that, you continue calculate for row s squared, s to the power of 1, and s to the power of 0 as usual. Okay. So from here, then you can determine the sign changes. So here, how many sign changes? So there are no sign changes because this is positive, 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 positive. So no sign changes, meaning that the system is stable. Okay, no poles on the right hand side of the S-plane. Okay, so let's look at another example. So let's say you are given a very long polynomial here. So you can use the Routh Hurwitz table to determine the stability, or to determine the poles on the right hand side of the S-plane. So here, first you fill in the first two rows. So here you have s to the power of 8. So s to the power of 8 as the topmost row, followed by s to the power of 7. And then you fill the boxes by the coefficient alternatingly. So 1, here is 1, and then 12, 22, 39 here, 59 at the bottom, and then 48, 38, 20, and then you don't have any more coefficients, so you put 0. Okay, so no more coefficient, you just put 0. And then you calculate for S6, s to the power of 6. And then s to the power of 5, s to the power of 4. And then after you calculate s to the power of 4, you calculate s to the power of 3, you will get 0. So here you get entire row of zeros. So you look at the row above, s cubed, which is s to the power of 4, and then you form the polynomials. So the polynomial will start with s to the power of 4 plus 3s squared plus 2s naught, or s to the power of 0 equals 1. So you don't have to write s. And then from this polynomial, you differentiate the polynomial. So you will get 4s cubed plus 6. And then you use this coefficient of the polynomial, replace the zeros in the s cubed. So the s cubed rows will become 4, 6, 0, 0. And then you continue as usual. Okay, so you continue as usual from here just now, s cubed. Okay, you can choose to simplify or not simplify. It will produce the same results. So here s cubed, and then s squared, s to the power of 1, and s to the power of 0. You just continue as usual. And then from here, you determine how many sign changes. So here you'll see that there is one sign changes here, from positive s to the power of 7 to s to the power of 6, there is one sign change. And then from s to the power of 6 to s to the power of 5, there is another sign change. Apa ni? Okay, so two sign changes. So meaning that there are two poles on the right half plane of the S plane. However, from this bottom, there are no sign changes. So no poles on the right half plane. Apa ni? Okay, so meaning that the system is unstable because there are poles on the right half planes. Okay, so hopefully you understand. Then you can try question number 2, quiz 10, okay? And the question, just let me know. Oh, ada soalan. Sir, in page 12 of the slide, can you explain again the sentence because symmetry no left? Okay, sekejap Alright, so in the previous slide, actually I also don't understand. This is older slides, so I don't know what they are trying to say here. Slight changes. Alright, symmetry, not left outpost. Okay, I will double check this one, and I will get to you maybe next week. Okay. I also not sure what this slide is trying to say, but I will get back to you next week. Okay, any question for quiz number 2? Question number 2. Okay, so for this question, you need to simplify the block diagram first, and then after that, you carry out Routh Hurwitz as usual. Okay, So most of the time you are given this kind of block diagram. So this block diagram, if you see that the feedback has no box, okay, so whenever the feedback has no box, meaning that the feedback equals, the transfer function for the feedback equals 1. So whenever transfer function of the feedback equals 1, we call this unity feedback, okay? Unity feedback meaning that the transfer function of the feedback equals 1. So sometimes in exam, you are given a question asking you to a question that says that you are given a transfer function of a unity feedback system. So whenever you see the word unity feedback system, meaning that the system has feedback equals 1. So sometimes the question on exam, final exam, will give you by words only, so without giving you diagrams. So sometimes the word like unity feedback, so you need to know about what is unity feedback. Okay. Okay, so so this is the end of the lecture. Okay, lecture 3G. So I want to give you a take-home quiz. Oh, online pun ada take-home quiz. Astaghfirullahaladzim. Okay, so take-home quiz 25 marks. So this is an example of past year question. So semester silap kat sini 2018, 2019 sem 1. Okay. So the same due date for quiz and also take-home quiz. So basically in this quiz, take-home quiz, you are given 3 cases for Routh Hurwitz criteria, but the question asks you to describe how to use Routh Hurwitz table to determine the stability. So based on this past year, most of the students, they don't know how to describe the method. Actually, the answer is simple. You just write, draw the table, fill in the table, the first 2 rows with the coefficient alternatingly, and then calculate the determinant. For question number 2, whenever you have 0 in the first column, you reverse the coefficient. For example, question number C, whenever you have zeros in the entire row, so you need to differentiate the row above. So that's the answer that I'm looking for. But most of the students, whenever they look at the word describe, they stuck and they don't know how to do. But it's actually a simple question only. Okay, so try to do this question. If you have a problem, just let me know. Okay, so submission to the email bmm133613, and also the same due with the quiz. Okay. Okay, so any question for this topic? Semua pergi makan nampaknya. Okay, so the reason why I give you quizzes a lot for Routh Hurwitz, because starting next week and week onwards, you will use Routh Hurwitz criteria a lot, but what I would say, there are a lot of usage for Routh Hurwitz, but maybe sometimes you already forgot about Routh Hurwitz, how to use the table, how to calculate the determinant, because the subsequent lecture, there are a lot of usage for Routh Hurwitz, and the calculation is very simple. But if you forgot how to calculate, how to do the Routh Hurwitz, then you will basically don't know how to answer. You can answer the whole question. Okay. So I want you to really understand Routh Hurwitz criteria to prepare yourself for the next lectures. Okay. Okay, so that's it for today's lecture. I will upload the video later. Okay. Any question? Yeah, any question?
Nak tanya, kalau feedback tu memang kita kena solve feedback dulu lah.
Feedback yang soalan tadi quiz
Mana-mana.
So kalau dia bagi transfer function dalam block diagram macam ni, kena simplify block diagram dulu. So
Maksudnya
Routh Hurwitz criteria mesti kena guna closed loop transfer function, meaning that transfer function yang dah simplifiedkan block diagram tu. Okay?
kita cari CS over S lah, kita solve yang benda tu lah.
Yes. Betul.
Terima kasih.
Okay. Okay, so any question before we end our session?
Tak ada all.
Tak ada. Okay. Okay, so that's it for today's lecture. So thank you and Assalamualaikum. Bye-bye.
Waalaikumsalam.
Salam sir. Bye-bye sir.
Bye.
Thank you sir.
Thank you.
Love you.
Yeah, love you too.
Love you more.
That's it there.
Okay, bye-bye.